Right, so it's 10:20, so you can just start whenever you're ready.
Okay,
Good luck.
thank you. Hi everyone, I'm Nahid. I'm with you from Toronto, Canada tonight. Actually, today, I'm talking to the future. I'm a backend developer specialized on application architecture. Today we're going to talk about common mistakes and misconceptions in web application security using OAuth 2 and OpenID Connect. You can find my contact info on the screen in case you wanted to connect, which I will be very happy to. And I'm currently a software architect in McAfee. As about me, in the next 60 minutes, we're going to talk about the specs, OAuth 2 and OpenID Connect specs. I'm going to go over specs which you may already be familiar with, but we're going to go over the details and also going over some best practices about these items and also talk about future of these concepts. Following that, I will have a quick demo using Identity Server 4, which is an open source library for OAuth and OpenID Connect. I'll do my best to leave some time for questions, but you can also reach me over Slack for a question, for chat. I'll be very happy to. I'm very passionate about security concepts and I consider myself learning all the time. So then feel free to just reach out to chat. So, one second. Okay, let's get started. Let's talk about authentication and authorization. These are the two of the main problems on modern web applications. They like authentication is about who you are. That's like verifying the user to make sure that this is who they say they are. And also authorization is about what you can do. It's like this process deals with granting or denying rights to access resources. Like as an example, just imagine an application which is managing the data on behalf of the user. So this application should do authentication to make sure the user is who they say they are, and also needs to make sure this user who they are, so they can access just the data that they are allowed to, which means to authorize the user. Here is a big picture of how modern applications may look like. And so in this picture, you see like different scenarios. Like for example, browsers communicate with web applications, and browser-based applications communicate with web APIs. Also, like native applications communicate with web APIs. Server-based or no UI application like devices connect with the web APIs. Also, like web applications connecting to the web APIs as themselves or on behalf of the user. Also, web APIs can communicate with each other, again, as their own or as or sometimes on behalf of the user. So, and typically each and every one of these relations that you see, they need to protect resources, which means that they need to implement authentication and authorization. Every time we talk about resources and protection, so both of them are matter. We need to know who is this user. Also, they need to access just what we want them to access or what they have access to. So the solution for these is OAuth 2 and OpenID Connect. So OAuth 2 is the industry standard protocol for authorization. It is actually a delegation protocol. It means that it's actually letting someone who controls a resource allow a software application to access that resource on their behalf. Means that the user is owning the data, but they are delegating this access to a software. So OAuth works over HTTPS, and also like OAuth can work on devices, APIs, servers, and applications. And the way that it works is using access tokens rather than credentials. In fact, OAuth came to the picture for delegation, and also like to avoid the password anti-pattern. OpenID Connect is the standard, open standard for the authentication. This is the most recent. This is not the first one. The Federation Identity, and also like SAML, and now OpenID Connect. OpenID Connect, in fact, is a simple identity layer on the top of OAuth 2, and it actually extends OAuth 2 for authentication scenarios. So if you're interested to know, OAuth 2 is being developed with the OAuth working group of IETF, which is Internet Engineering Task Force. But OpenID Connect specification is developed by OpenID working group. These are two different like organizations, but they are connected. Now that we know the problems, we said that the problems are authentication, authorization, and also we saw the big picture, right? And now let's look at that big picture with the solutions, right? So as you see on each of those lines, I draw that like how OpenID Connect or OAuth 2 can come to the picture and solve our problems, right? So if you see at the top, like at the top, there is authorization server added as well. So we're going to get deeper into this, that how this has to work, right? So, but to go through, let's say, I want to say that OAuth 2 and OpenID Connect are actually open standards, means that anyone can implement it. There is no actual implementation proposed. It's like there is different libraries and providers, but the specs is providing us the standard, right? So, and these are actually fundamentally very complicated, so which may lead to so many mistakes and misconceptions on implementation. So specs are more than like 400 pages, if I saw right, and also the point is that these specs are not written for developers who are using those libraries, right? The specs are written for people who are writing the library or the providers, the services, which there is so many of them in the market as well, as well as open sources. So that's why specs are not that simple to read as a developer who is trying to actually use those libraries. So let's discuss some of the details of this specs and also going through the best practices for this. To be able to actually go through that, we let's talk about the terminology, like some of these keywords that is all over the place. That what does this mean? So in the I'm gonna start with OAuth. The reason is that, as we said, OpenID Connect is in fact an extension on the top of OAuth. So if we do, I know like everybody is interested to know authentication and an authorization, but in fact, because OpenID Connect is on the top of OAuth, it's for the best if we learn the spec, if we learn the details of OAuth, and then say now like the extension for authentication works like this. So let's start with the roles. So when we talk about the roles on OAuth, so there is some keywords that they may seem very complicated, like resource owner, like which resource owner or RO is the user, is a person who is doing actually that delegation. It's like which is end user. If the client actually, it can be end user. So the resource server is the API, right? It's hosting the protected resources, and also it's capable of accepting and responding to protected resources requesting by this access token. So it's like in simple word, resource server is the service that exposes that data, right? So then it's API. Like in most of scenarios when we talk about resource server, we're just talking about the API. Client is actually the application. It's the application making protected resource requests on behalf of the user. So on behalf of that resource owner that we just talked about. And the term client can be like a web application, device, and even an API The first one is the authorization server, or AS. So the authorization server is the component which is issuing the access token to the client after successfully authenticating the resource owner and also obtaining the authorization, right? So after making sure that this is valid, this is the one that issuing the token. So the authorization server, you might see it as a security token service as well, which is like STS. Like these are the same if you saw the same keyword. The next thing in the terminology is the client type. Before I talk about client type, I should say the client that we talked about. So for a client, like it has two property. So each client has a unique identifier, which we call client ID. It's a public identifier for the apps, and it's like a random string. So, but it's suggested to not be guessable very easily, right? And another property that the client has is a client secret. The secret is known only to the client, to this application, and also to authorization server. So again, it's a random string, but it's better not to be guessable, and it's for the best to use like cryptography secure libraries to generate that secret. So the reason I said that, because now the type of client is related to that security, to that secret, right? So the first type of clients are confidential clients. So confidential clients are the ones that can actually keep that secret secure. So they are like able to securely authenticate with the authorization server, right? Like I'm going to provide some examples of this. And the public client, but is not like that. They are unable to hold this secret secure, right? It's like as an example, the spa apps, mobile apps, and devices are public clients. So they are running on the browser, on the internet, and also like devices are owned by a user. So there is a user, they have like a smart TV. Imagine the smart TV, it's in people's houses, right? So I know it sounds very, very hard, but it is not impossible that somebody read the content that we upload on the TV. Also, like, because user has the ownership, they can actually read the Wi-Fi communication or something like this, which means that they are not confidential, right? They are considered public client. And for confidential, like APIs, like web applications, like an MVC web application, which is on the server. There is another type of client which they call credential clients, just as an extension, which is more of a future concept. So it's like they have credentials, but then because they are mostly dynamically registered, so then it means that the authorization server cannot confirm their identity. It's just as a side note, just to know, like there is a third type as well. So here comes to the first note. So I decided to just show the note, like the best practices or stuff like that we learn. We have to focus more by this lamp, and the devices are public client. So this is a matter because in so many of examples, they just introduce devices or smart TVs as a confidential. The next thing in the terminology is scopes. Scopes initially proposed the concept of a scope by OAuth 2. So scopes are used to express what an application can do on behalf of a given user. And it's always, scopes are subset of what a user can do in the first place, right? So, so then they are just for handling delegation on behalf of the user. And because of that, as we said, that scopes are subset of what user can actually do. Scopes cannot allow an application to do more than what the user can do, right? The other, like here, and I have some example of the scopes. Like, for example, you can say order write, order delete, order read. So which these are like user can delegate order write to this application. So an application can just make an order instead of like on behalf of the user. The other concept is consent. The concept is like the application can request one or more scopes. This information then later presented to the user in the consent screen. And so then the user can actually limit those scopes, right? And say, like, for example, like application is asking, or even they have registered, I mean, they have access, the application have access to order write, order delete, but then on the consent, users say, I don't want this application to be able to delete this order, right? So most of you already seen the consent form, especially like when you try to log in using social media, which is more of OpenID Connect or authentication, but the same concept. So in general, the scopes that an application is requesting can be modified by resource owner, by the user, and also authorization server. Both of them can actually modify the scopes. There is a tip about scopes, which is very important, because in general, there is no standard. I mean, the specs doesn't say about the scopes. In fact, like scopes, like the access token, I mean, they can not be in access token. Access token can contain no scope, but like that's why like it's there is best practices about scopes that it say that scopes alone in an access token are not enough to carry on authorization decisions. So it means that they are not enough. So it's on the application to actually mix the scopes with what user can do, with user privileges to decide about permissions, right? Later in the demo, I'm going to show you a sample of this, that how they should be. This is a very important. And OAuth does not define any particular values for scopes, since it's highly dependent on services, internal architecture, and needs. But it is suggested that scopes does not carry the permission alone, right? So they have to be mixed with user privilege to decide about permissions on the APIs, especially. The next thing is access tokens. So access token is, like, as we said, OAuth is about delegation of the access using access token instead of credentials, right? So then this is one of the actually main concept of the OAuth. So access tokens are the things that application use to make API requests on behalf of user. And so again, for access token on OAuth, there is no defined structure that is required by spec. There is best practices for that, but it's not required, right? It's like the specs say that access token should be an opaque string, means that like it should not be transparent to the user, right? And it can be any random string. Bearer tokens are actually the most common type of or predominant type of access token used within OAuth too. But the spec doesn't require to do that, right? So here I have an example of access token, which is a JWT. JWT, or JSON Web Token, some people call it JOT, is an open standard. It has an RFC for itself, which define a compact and also self-contained way for securely transmitting the information between parties as a JSON object. Like, in simple word, it's a way to just send the JSON objects here and there in a secure way, right? And this information on a JWT token can be verified and trusted because it is digitally signed. So on best practices, it's suggested to use JWT for the access token. So if you see on the screen, so I'm going to try to actually. I hope it's big enough. So this is this screen that you see. I tried to decode a JWT token using JWT.io. It's just a website. So if you see, each JWT has 3 parts: the header, the payload, and also the signature, right? So what we talked about, the scopes, and you can see in the payload, it's the content of this token. And in the signature, so that's, you see the signature of this, that is say it's a sign and it's secure. So, but what I wanted to actually talk about is the header as well. So on the best practices, it is suggested to use JWT in the first place, and also using typed one. So if you see the token that I have there, it's the 80 plus JWT as a type, means that this is a access token, which is JWT. Means that if I have another JWT token, I can recognize which one is access token, and later when we get to identity token, you will see that one, the type, going to be different. So then I can say which token is what. This is suggested to do so. And yeah. So here as a tip, I have it logged a little bit to just make sure we do that. So to use typed JSON Web Token as a best practice to do, okay? So in general, JSON Web Tokens are suggested because of consistency as well, because it is consistent to use everywhere, and also they are self-contained. So when you use JWT, there is no need to round trip the authorization server to verify. But if you use a random string, right, to verify that the API, there has to be a round trip to the authorization server to make sure that this is valid, or figure out some other way to just validate that token. The other tip about JW tokens, which is very important, is that the JW tokens can be verified without doing a database lookup or round trip to authorization server, as we said. So that's why there is no way to invalidate a token until it expires. So it means that like if you have a token, so this token is up to client, and like client might make like a couple of calls to the APIs. So even if it's invalid, right? Even if you decide to invalidate that, there is ways, there is a standard to invalidate token and things. But if you don't implement other things or don't do it in simple way, there is no way to invalidate it. That's why it's suggested to use a short-term token, not like, because some of the software they use token for like a week or 2. So then it is, if it's in the wrong hand, so then you're going to be in trouble. I mean, the application going to be in trouble. The next concept to go through is the endpoints on the OAuth 2. We have multiple endpoints, but 2 of the main ones that we're going to discuss here is the authorization endpoint and also token endpoint. So authorization endpoint, which is the first one, is used to interact with the resource owner and obtain the authorization grant. So, on this, the authorization server first actually verify the identity of this resource owner to make sure like it is a valid one. I'll show an example of how this works. But also the token, and after that, the token endpoint. Token endpoint is the one which is actually used to obtain access token. Here I have example of authorized endpoint. So about the request, that how does it work to do authorized endpoint, which is a GET. So you send the client ID scopes, and then the response type, and the redirect URL. So it's just a sample thing to how it works. So when we get to the grants, so we're gonna talk about more details. But here it's just to say that in the terminology, there is an authorized endpoint, which is saying what grant to use. And here is the token endpoint, example of the post to token endpoint about the request, and also like the response. On the left, you see the request, which is to the token endpoint, the information required, and also on the right, on the top, you see the successful response, and below you're going to see the error response. And if you see the access on the top right, we have access. We have actually token response, which contains access token, token type, and also refresh token, expires in. So within this, the access token and token type are the mandatory one. The expires in is recommended, but the rest are optional and can be not there. And for the errors, there is different errors involved, like invalid request is an example. Like you can have invalid client, invalid grant, and but this is the standard to how to get the response, which is very actually descriptive. Here I have a high-level diagram of how this works. Now we know these keywords in the terminology. Now when you see the resource owner, you know that this is the user. When you see the authorization server, and when you see the resource server and also client, you know that you would know that this is the application which is asking for a resource, right? So this is very, very high level, just to show how the round trips to each other is happening. But we're going to go further to the details of the grant. This is just to give you a picture of how, in general, in the high level, in abstract, things work. Grant types. For the grant types, actually, grants are the flows, are the solutions for different use cases. It's like I have this use case, for example, I have a mobile app. Okay, what's the solution with OAuth? I have like a web app. What is the solution OAuth gonna suggest to me, right? For this, if you see, I have them with different fonts, right? So you see client credentials, but you see authorization code and password and implicit in different font, because some of these are legacy grants and they are not suggested to use. And we're going to discuss like the ones that are not legacy with more details actually. And let's go to client credentials as a first one. So client credentials is the grant type, or is the flow as you see in the picture. It's a flow that client is asking, is authenticating. It's sending their client ID and client secret, and then they're going to get an access token to be able to call an API. And based on this sample, you see that there is a client secret involved, right? This means that this must be confidential client, right? So, and this is true. This grant type is to obtain access token for a client, but out of the scope of user. This is not on behalf. When we had that big picture, we said, okay, sometimes this web application or this API, they want to access each other, but they don't want to do that on behalf of user. This is the grant suggested for that. This grant is suggested for server to server, as we discussed, and also for confidential client. But for this grant as well, like access token can be any string, but it is suggested the best practices for this grant is to use JSON Web Token as well. Because like even if you do the call not on behalf of the user, but you do to the same API, right? If we use another access token type and not the JWTs, so then we need another code, another infrastructure to be able to read that access token as well. But just in favor of consistency, it's suggested to use JSON Web Token for this as well. And also HTTPS. I know this is server to server, but honestly, HTTPS is the only thing protecting requests from being intercepted or modified. So that's why it is suggested. So let's go to the next one. Authorization code grant. Authorization code grant, we said it is legacy, and it is suggested to not to use it. But authorization code grant is actually base for the Pixi. Pixi is the next one that we said, okay, it's not legacy. That's why it's good if we go through this. And I want to go through this and say why it is suggested not to use it. And then now the one that is suggested to use it, what it is. So on the left, you see a high-level diagram which shows how authorization code grant works. So it is used, let's say, by confidential and also public client to exchange. It's based on exchange authorization code for access token. So first, the client is requesting a code from the authorization server, and then going to exchange it for the access token, right? Then there is two processes involved here. So this grant is using front channel to get the access token, which is the less secure one, and then it uses the back channel to exchange this code with the with access token, which is the highly secure way to get that. All right, and also in this grant, what we do is that we are sending the return URL as well. Like we say that when we ask for the code, we say this is the redirect URL, and then so this redirect URL is what gonna redirect you, and also it's registered for client. If I want to go through that again from the top after this description, I would say that, okay, like the client is going to authorization server using their identifier if they are confidential, using actually they're just on the identifier, and then they say this is my redirect URL, and with this redirect URL, client is already registered on the authorization server. It means that there is another check that this authorization server going to check that redirect URL is mapped and it's correct. And also they will send this state, which is for like cross-site request forgery attack actually, but it's not tied to the code. What is happening on the front channel, the authorization server going to redirect back to the client with the code, right? And then after that, client gonna request again. So you see on the right below that it would go to now to the token endpoint and say, okay, now exchange this code that I have, right? I received in the previous step with this with an access token. Just exchange this with access token, and it's gonna send the redirect URL again, right? It will say, okay, so that was it. And also, like for the confidential client, it will send a secret as well. So, but secret not for the public clients. So for confidential client. So this flow was actually originally requested for mobile applications, right? But there was like a couple of attacks which was reported on this flow. That's why they said don't use it. Let's see what was those attacks. So the first attack, which was authorization code interception attack. So this was for public clients. So which was reported. So the diagram that I have is for smartphones, is for phone applications. So in the for the public lines, as I said, we don't have any secret, right? So then as long as somebody grab that code, somebody can access that code, they can just go and exchange that with the authorization server. So on their smartphones, like just imagine I have an app and then I have a malicious app, right? This malicious app is just registering itself under the same redirect URL. Correct. And then after, like when the authorization code is back, the operating system browser might return to the malicious app or to the legitimate app, right? If each of those can happen, that's why it is not a full line. So, and then if the malicious app receives that, so they can exchange for the access token, right? They don't even need to be like a copy of that app. They can be any app, right? As long as they can be there on that smartphone and they register themselves on the same redirect URL, so they will work and then they exchange. So I know you might discuss that there was a state parameter, but it's not tied to the code in the authorization code. And this was just for public clients, right? There was, and you might say, okay, now for confidential, so why not using that? So there was another attack which called authorization code injection attack. It's a more complex attack, but in fact, this one is like, just imagine it is actually happening from a legitimate client, right? So on the authorization code injection, so I have a client, so which is the user. The user try to log in, and then just imagine there is like a browser extension on their machine or something that when they try to log in, when they receive actually that code back, now like malicious like extension going to grab that code, right, and send it to the attacker. Attacker, in fact, has a client, which is legitimate client, right? But then they don't have the username password of this user, right? So just imagine this user is already authenticated and everything, but they want to have the same access that this user has. What they would do is to just get that code. Okay, this is confidential client. They need secret. That's why they use a legitimate client. So they would use this code. And from the same app, from their client, they try to initiate authorization code grant. They would go to the server, and then once they receive the code, for the next step, instead of they try to exchange code with access token with their own code, they will replace the user code with that, and then they exchange. This attack is called authorization code injection. Means that it's not even from a malicious app or malicious client. It's from a legitimate client, but within an attacker is using that. It's not our actual user using that. That's why it is such a sad to do not use authorization code grant and use Pixi. But what is this Pixi? So Pixi is a proof key code exchange. There was an RFC on 2015, I guess, for Pixi. So Pixi is here to fix that problem. The problems that we talked about, this Pixi is to fix that. But how it's trying to fix that? Just imagine for the Pixi, when we use Pixi for public clients, it does the same, right? For public and confidential, it will receive the code and then it would exchange the code with the access token. But what it does, it has actually, just imagine, like we said, that for confidential, they would use the secret to exchange the code with the access token, right? The secret is to guarantee that, hey, this is the client, but then the attacker would actually attack that as well with just using the legitimate client. But here on Pixi, this secret is like imagine a dynamic secret way, right? It's just that on each request, on each of this flow, the full one, it's like there is the authentication is happening. Why? Because the mechanism is in a way that when just imagine this client has a code verifier, which is a random string, right? Just they would say, okay, I want this, I have this like random string that I generated. So when I want to, on the front channel, I'm asking for the code, right? I go to authorization server. I'm going to send the request, the client ID, redirect URI, and the other things which was already on authorization code flow. But along with that, I'm going to actually send them this code verifier, and also but in a way with a method, I'm going to, like, for example, hash it, right? So then they name it code challenge, means that it's the code verifier, which is hashed or secured, but then also the method that is sent to, right? So now I'm sending a random string with the method that I generated this random string to the authorization server, right? So authorization server is getting that. And later when I receive the code, it redirect back to me, and then I receive the code. So now when I'm asking, like when the client is asking to exchange this access token, they're going to send the actual code verifier now, right? The code verifier, the random string that they had without hashing or encrypting or doing any cryptography like function on that, right? They would send the actual one. So in the first one, the challenge is sent there, which is the modified code verifier, the encrypted one. And in the second one, the actual code verifier means that authorization server now has a chance to check, yes, this is the same one. Why? Because they received the method before, and also code challenge. Now with that code verifier, when it's sent, they can apply the same method on the code verifier to make sure these two are the same, right? So that's why there is guarantee that the same client which actually requested the code and received the code is the same client is exchanging the access token with us. That's why it's secure. And it is suggested for the previous attack reason that we talked, suggested to use Pixi for both public and also confidential cloud. There are some tips about Pixi. So this is like, as we said, for a stolen authorization code attack and also code injection. So there is a very good tip about Pixi as well. So which actually can, we can be in trouble if we do that. So which is the redirect URI. So redirect URI must be compared using exact string match for the Pixi. So this is a good tip to do that. So imagine, like, this is an example that can go wrong. Like if you register, because some of the providers actually letting you do that. So if you, for example, register the first one, so the attacker can go with the third one and just return back, like as a redirect URL, can receive your code. So it actually helps to detect mix-up attack. So it would take very long to explain mix-up attack, but it's good to know that redirect URL can help us on that. Also, do not use referrer HTTP header. So even if you use Pixi, so do not use referrer HTTP headers. This is in the best practices, because if you use HTTP like referrers, the leakage can happen from like OAuth client and also authorization server. So like just imagine when you receive code or even the access token, if you have a link out in that page on somewhere else, it can cause leakage. Okay, so I'm not going to go deep into how the leakage works. So the password grant and there is a password grant and implicit are two of legacy one. So I guess I'm gonna skip those. But they are on the deck. You can go over them. I'm gonna share the deck actually. But the best practices say use Pixi instead of those, and also implicit grant. So implicit grant, just let's say implicit grant was suggested for the JavaScript applications. Because like at 2012, like we wouldn't be able to actually make a goal from a JavaScript to another domain, right? So that's why they simplified authorization code flow and they suggested to use this implicit grant. But this is not the case. We have course and the solution is there. It's not suggested to use this anymore, because now we can do AJAX call to other domains, and this is not the case anymore. So that's why it is suggested to use Pixi instead. So now if we go back to the terminology, so it's better to say that, okay, here, like just client credentials and Pixi are the ones to be used. So refresh token is the last thing on the OAuth. So it means that, so for the refresh token, if when you receive an access token and this token is expired, so when you use it, invalid token, so you like refresh token is to have a chance to just ask for a new access token, right? So for the confidential clients already, when you ask for a refresh token, we are actually requesting the secret, but not for public clients. So that's why for the public clients, the best practices say that use sender constraint refresh tokens or do the refresh token rotations. So this is suggested like sender So here I have that. So sender constraint refresh token is to tie this refresh token to the client, just to make sure the same client who had the access token with the refresh token is actually requesting for the refresh token. And one-time use is actually, it's suggested. I mean, in the future, it's going to be in the spec. So it's just in case that things go wrong and the attacker received actually a refresh token. So just make sure that it's used one time, right? And even if the legitimate client who didn't receive that refresh, I mean, like the refresh token was used, but this client which had that because of one time, like they wouldn't be able to use that. That's okay. Just it's one client, and there was an attack. So then it's better to know instead of just doing nothing. So here I have some use cases which show like what is the, like we talked about authorization and authentication. Here I have something to just convince you that we need authentication here. So for the delegated authorization, yes, it is authorization. But then when we talk about SPA login, SPA app login, mobile app, and single sign-on, these are all authentication cases, right? Something is required, and OAuth though is not for authentication. The reason it's because so like we talked about like highlights in the terminology, right? We just skipped the detail, but like here there was no standard way to get user info. We didn't talk about actually user info. Also, like every implementation for authentication is different. Yeah, some people use the federation authentication, SAML, but then there was no standard for that. And also, like there was no common sets of scope actually for like this user info, or just to say what is data about this user. That's why actually OpenID Connect came to picture. So this is actually the most recent standard or technology for authentication, but this is hand-to-hand with OAuth too. As we said, it is an extension on the top of OAuth, as I tried to demonstrate in a very simple way. That it is on the top, it's an extension on the top of OAuth too, and it uses OAuth to all of, and then I'm going to get there actually in a bit. So on OpenID Connect, there is a couple of new concepts added, right, in the terminology. So first of all, on about this, like I'm gonna just talk about the things which is added, not the things which are shared. Like when, like on OpenID Connect, when we read the spec, we see a concept as a relaying party, right? Relaying party or RP, which is actually the client, right? This is a client which accept, which support OpenID Connect. So then, like the same client that we talk, if it supports OpenID Connect, they call it RP in the spec. And OP or OpenID provider, again, it's an authorization server which is capable of authenticating the user and providing the claims related to this authentication to the relaying party. So then these terms is actually, this is like authorization server and client, but like in the spec, they just have different names, right? So here is a high level of how OpenID Connect works, right? In the high level, it's just they relaying party asking for authentication, asking like the OpenID provider asking for authentication, and then having that back, and then like it's the rest, like having a identity token or eventually access token back, and also asking for the user info. Like here, all over the place, you see the user info, because like yes, this is one of the things added. We're going to get to the endpoints. Sorry, I'm trying to go to faster pace because I'm checking the time and I still have a lot to say. So for the scopes, actually, it's one of the things which is special about OpenID Connect. We said there was no common or standard scope about users or authentication in the OAuth, right? But OpenID Connect comes that, like it say that, yes, there is a standard. The scopes can be used to request some specific set of information make about user and make them available on claim values. This is a big difference. Consent is the same. So, but with the difference that on the consent on OpenID Connect, when we show the consent, so we don't say, do we want them to use, I mean, we do say if that's the case too, but we say, okay, user, do you want me to return this information of you to this application? So then it's a bit difference now when you have just OAuth, and then when you add OpenID Connect, it's actually added to that. In addition, what to do, also what to expose to this application would matter. And also, like as a tip, like OpenID Scope is mandatory on OpenID Connect. There is another concept which is on ID token. So, which is on OpenID Connect as an ID token. It's again a JWT token, which contains claims about the authentication event, right? So, and it may contain other claims as well, but now you see that it has information about when authentication happened and then when the ID token issued and things like that. But in OAuth token, there was no information about this. If you see the top, now I have actually an ID token on the screen. If you see the top and the type, it's now JWT, like we had 80 plus JWT, right? So it means that if I have two tokens, right? So this one is identity token, the other one was access token, right? And here, like in the payload, you can see like properties which are related to the authentication just happened, right? And it's not just about scopes, which are for authorization for delegation of access. So, and so when we come to OpenID Connect, there is more endpoints added. So the main one, which I said user info, we saw user info here and there everywhere, that this is actually one of the things added for OpenID Connect. This is an endpoint can be used to retrieve identity information about a user. In the high-level diagram, when we saw is that the relay party actually gonna ask for authentication, and after that gonna ask for user info, right? This endpoint, and this was what was missing in the OAuth, right? We needed something to know, okay, this user who logged in, who was that user? And also discovery endpoint, you might see this in the OpenID Connect providers. So it retains information like issuer name, key materials, and supported scopes. Like most of them has this. This is in the spec. So this is an example of user info endpoint. And if you see, like for user info endpoint, we need to send the access token, right? To be able to access that, which means it's authorized. And a sample of the results is like that. I get actually information about this user, like as many as user let us to return, right? Give consent to return. So on OpenID Connect, terminology is again, so it was authorization code implicit as well, but for the same reasons, actually the exact same reasons, they are not suggested to be used. But Pixi and hybrid is the ones that are safe. So I'm going to quickly go through the hybrid one. So on hybrid grant is like the Pixi is exactly like how we described that, right? So the only difference about Pixi is that we are actually sending the OpenID scope as well to the authorization server or OpenID provider. And then after that, that's the authorization server, which is now OpenID provider, which is going to handle that and challenge that and like showing the login to the user, which means a centralized login. That's actually one of the biggest purposes to do that, to have that, right? So then if this authorization server is OpenID Connect provider, so the only thing you need to do is to send OpenID scope. And the hybrid one. Hybrid is actually good to know about that. So hybrid is safe, but so for hybrid, what we do is that we're going to receive an authorization code flow. We're going to receive ID token in addition of the code, right? And then we exchange that code for the access token. But there is a difference here, which they call it hybrid. And the hybrid, there is a property you see here as a C hash. It's actually the hashed version of code. So which means that when client receives that, it's going to compare this hashed version and it received the code and it's going to do the code and it's going to compare them to make sure that it is the same, to just make it secure, right? But the downside to this is that, so as you see, because we said on the front channel, it's going to receive code plus ID token, means that ID token is received as in front channel, which is not secure. So it might leak additional personal like information about user that you don't want to, right? Also, like this mitigation step that we talked about, this thing that compares C hash with the code, is that it is actually need to be implemented on the client, which result to more complicated client library, which is not suggested much. And it's better to handle everything like on the server, not on the client. So that's why it's suggested to use authorization code plus Pixi or Pixi for all clients. Here I have some use cases. I have these use cases like it's a web app, native mobile app, and a spa app. All of them is suggested to use Pixi. These are the accesses to, like we try to explain why. I hope I could convince you. And for APIs for server to server communication to receive access, the client authorization is what is suggested. So I have actually a couple of these are on my deck. It's about best practices about spa apps and native apps that I'm not sure that we have time to go through that. So okay, I wanted to do a demo. I have 5 minutes, so I'm going to show you a quick demo. So here, I would need to stop presenting and then re-present. So here I have an application. Oh, something happened with my Windows. Sorry. Here I have an application which I wanna show you actually like different scenarios using Identity Server 4, which is an open source library for OpenID Connect and also OAuth. So I just want to show you quickly. Oh, it was here. I want to show you quickly that like all the stuff that we talked about, how easy it would be to, if we use the right library, if we use the right provider, right? I'm going to share this code because I'm not sure if I can just show to you everything. So I have this like all the scenarios here listed, but unfortunately because of favor of time, we couldn't do that. So here, like, let me show you a very quick demo of this client authorization flow. in this model, what I have is that I have, in this model, I have an identity server project, so which is authorization server for OAuth, and also it's OpenID Connect provider, right? So this one, like here, to be able to implement that. So I have a client registered here. So this client is as easy as a console application. So here, all I said was that now I have this client, and this client is a console app. So I'm going to do client credentials, and it has a secret because it's a confidential. And also I say that what is the scopes that I want this application to have access to. And now, like on my application on this client thing, so just I'm going to receive a token. So using, let me show you the code. So here, receiving token is as simple as just make a call to this authorization server that I have, okay? And just say, give me a token for this. And just say, this is my client and this is the scopes that I want to access to. And that's all. And I'm going to have a token, which later with this token, I can call an API. But then this call is not on behalf of any user. This call is actually on, like, this console app is doing the call. And look at this. So now I'm trying to receive the token, right? This is my token, and then I call this API. So on this API, this is like OAuth information received, so which called an API. So now I'm going to call like a delete API. See, like because of the access issue, now I didn't have access. I'm trying another token, and now I have that thing. Let me show you what was that not access. Like, look at this. Now I'm trying to call an API with different scopes just to demonstrate how the scopes are working, right? So, and here I am this is what actually I wanted to show you. So here I have an API. So look at this API like this. I'm not showing you actually how to write the code on an API or how to do an endpoint. It's just to demonstrate how the things are working. So this is my API. I'm going to share my code. So remember the tip that we talked about scopes, right? I said that scopes are saying what access, right? But we said that this is the API that at the end need to decide about permission, right? So here to demonstrate that I have this API, so which is like me, like I wanted to say that, okay, now this is the API and just the user can do that, right? So I go here and I say, okay, call this user API. When I come here for this, so I would check if you see here, there is no name for this identity, means that it wasn't on behalf of a user, right? Just to show that. So here, like I'm gonna just return that, means that on this API, with the scope was full when we called this, like I had like write and delete and read access. But then because the user is not logged in, we would say no, means that like combining user privileges plus the scopes. That's what I wanted to show you. Okay. Sorry, I'm out of time. And I'm going to share this code. It's I have on this code I have this is repo. Also, I have client authorization. I have code authorization with Pixi, and I have JavaScript client, and I have some older like .NET 4 applications using that as well. And I hope it will be useful. Sorry, I didn't leave any time for questions. If there is any question, so I guess maybe like for 2-3 minutes. So feel free to ask. I'm so sorry if I talked very fast. I try to and there is like the future remaining. So, but then I'm gonna have the slides there, and on the slides I had this future thing just to talk. But then now I'm going to do a modification. I'm going to list them in the slide and give you the chance to review those. yeah, I get so excited myself when I talk about these concepts. And yeah, if there is any question, please feel free to ask me in the Slack channel, or even now if there is something.
Yeah, Nahid, this is Dinesh here. I have a question regarding the attack which we were talking about on the authorization code flow. Our company is actually, using OAuth and OpenID Connect heavily, and we have implemented hybrid code flow. So, do you think the hybrid also is prone to the attacks?
Pardon?
Hybrid code flow is also prone to the attacks. I mean, it can be attacked.
So the attack that we talked, no, hybrid should be good for the authorization code, for interception and also injection. No, as we talked, that the hash of the code is actually providing the attack. So it means that this is suggested use Pixi or hybrid. But for the hybrid, as we talked, so there is heavier logic on the client to match this code, the encrypted code, right? So
Yep.
but no, like it's suggested for OpenID Connect using Pixi or hybrid flow. But like Pixi is like a easier one because client is not involved with the logic.
Okay, thank you.
Yeah, it was. Okay, I guess we are good. Thank you.
Yeah, I think
everybody.
that's good.
Yeah, I'm. Yeah. Okay, good. No, actually.